Here we go. By the end of this lesson, you'll be able to describe how an arrow depicts a vector, measurement, add and subtract one-dimensional vectors, apply 1D vector math to resultant velocity scenarios, and calculate unknown sides and angles of right triangles. Sounds riveting. All right, quick review. Scalar measurement is one that just has magnitude, does not have direction, it's just a number, versus a vector measurement is one that has both magnitude and direction, communicates how much and in which way. Good with that. So, pretty sure those are definitions that you already knew. Give that one a shot. Tell your neighbor. Correct answer is E. Which two? Speed and mass do not have direction. Displacement, acceleration, and velocity are the three vectors you know of at this moment in time. More are coming. Okay, so a vector can be represented with an arrow. So the way the arrow is pointing communicates direction. That's pretty self-explanatory. But the magnitude, that is communicated by the length of the arrow. The longer the arrow, the greater the number, the greater the value of that vector. Okay. Tell your neighbor. Is everybody okay with C? Okay. So they're going in opposite directions. The tortoise is going slower than the hare. So the length can represent distance, but also represent speed. It can also represent how fast you're changing your speed for acceleration. Okay. Resultant. When we say what's find the resultant, this is the sum of vectors. You're adding them up. We're going to say resultant, think sum of. The resultant. Okay. All right. This is brain busting. You ready for this? 7 to the right plus 3 to the right gives you 10 to the right. Whoa. 7 to the left plus 3 to the right give you, man, you guys like born for physics. 1 up plus 4 down gives you 1 up. 4 down plus 5 down gives you, man. Okay, so that's the extent of finding the resultant of vectors in one dimension. It's just that easy. Okay, just a little foreshadowing. When we graduate to 2 dimensions, what we're going to try to do is break 2 dimensions down, simplify it to 1 dimension stuff. So the math becomes that easy. Okay, I'll let you know when we get there, but tell your neighbor. So we go with A. Next. Tell your neighbor. So everybody go with B. See what I'm doing there? So up, it's positive direction. So I can communicate direction with sign, positive, negative sign. Go to that. Correct answer is C. So notice I can represent this as acceleration as well. Okay. Correct answer is C. One thing I want you to note, do you see how vectors are different than just straight up numbers? Like if we did 3 plus 3, it'd be 6, but this is 3 to the right plus 3 to the left is 0. Okay. Okay. Tell your neighbor. Correct answer is C. You got 200 meters a second plane's velocity, and you have 40 meters a second the wind. The resultant velocity of the plane relative to the ground is 240 meters a second. So what happens if the wind's blowing the other way? Tell your neighbor. There we go with B. Okay, so this is a thing. Typically in the United States, weather patterns come out of the west and they go to the east. So if you're flying out west, you're going against the wind typically, and it's going to take you longer because you're going slower. Versus when you're coming back home, the flight actually takes less time because you're going with the wind. So it's adding that velocity, like the wind velocity, plus how fast the plane's flying through the air. You get home faster. Good with that? And this is just a little side note. If you're ever driving cross country, like especially through the plain states, Nebraska or Kansas or something, no trees, you get better gas mileage coming home than going out because you're going against the wind going out and going with the wind coming back. So, tidbit of information there. What's the resultant velocity of the bird? 0. The bird is flying just as fast as the wind is blowing. Good with that? Talk to your neighbor. Correct answer is B. What's that going to look like? You're swimming this way. The current's going that way. Probably shouldn't be swimming in that river. That makes sense? Okay. So do you see how resultant velocities can be played out in life? Okay. All right. What's another way to write A minus B in math class? A plus a negative B. Good with that? Okay. With vectors, what does it mean if a vector is negative compared to positive? What does that communicate? Does what? Goes in the opposite direction. Okay. So what this means is when we subtract, we're going to make B negative. So it makes the vector go in the opposite direction. Okay, it makes the vector go in the opposite direction. Good with that? So I'm gonna walk you through this first one here. So we've got 2 minus 6. The negative is applied to which number? 6. So what I'm going to do is I'm going to make the 6, I'm going to flip it because I'm doing plus and negative. So I'm making this go in the opposite direction. And then I add 2 to the left plus 6 to the left gives you 8 to the left. See how I did that? You apply the negative first, causing this vector to be flipped in the opposite direction. That took care of the negative. That took care of that. And then you just straight up add it. Find the resultant. Okay? So that's how you subtract stuff. Try that one out. Tell your neighbor. Tell them how you got there. Correct answer is? Answer is B. Go to that. Flipping the green arrow down because the negative was applied to the green, to A. Tell your neighbor. Okay, correct answer is B. If this was plus, it would be what? 0. But it's minus. So you gotta flip it first. How are we doing? All right. I'll give you a quick hint. How do you find the change in anything? Final minus initial. Tell your neighbor. So change in velocity equals final velocity minus initial velocity. You got a negative 2 meters a second minus positive 3 meters a second. So taking what we've already known how to do, but looking at the vector wise, we're flipping this the other way. Negative 5 meters a second. Good? Okay. Okay, switching gears. Quick confidence rating on trig functions. Sine, cosine, and tangent. 5, rocking the socks off of this. 1. Okay. Here today is devoted the rest of the hour to get everybody to like a 4 or 5 on trig functions. Okay. This is an essential skill for the rest of the year. If you don't own this, life is going to be rough in this class. Okay. I'm just kind of like setting the stage. You got to know how to do this. Okay. If you looked at this and like, well, why did you write sin on the board? Like, you probably should have dropped the class when I said you should be have already taken geometry. Okay. So, the default variable for an angle is theta. Okay. So when we talk about sine, cosine, and tangent, we've labeled the sides opposite, adjacent, and hypotenuse. Okay. where do these sides come from? So what kind of triangle do you have to be able to use sine, cosine, and tangent? A right triangle. Okay. So one side is 90 degrees. Okay. When we're using sine, cosine, and tangent, the labels of opposite, adjacent, and hypotenuse are always relative to this angle that we're trying to identify. Okay. The opposite is the side opposite of that angle. That's where that gets that label. It's opposite of the angle. Adjacent means touching, next to. I've got two sides that are technically adjacent to this angle. Which one's adjacent? The one that's not the hypotenuse. Okay, how do you know which one's the hypotenuse? The one that's opposite of the 90 degrees. This one will always be the longest side. I don't know how to spell that. I don't know. Hypotenuse. Okay. Which leaves this side to be the adjacent. Oops. Okay. Good to that. So sine is equal to what? Opposite over hypotenuse. Okay. Cosine is equal to what? And tangent is equal to what? If these have not yet been memorized, make it so. I don't care how you do it. That needs to be memorized. That should have been memorized at least by last year, if not earlier. Okay? I don't care how you do it. Some people like Chief Sokatoa. Like that never helps me because I don't spell very well. Dr. Mason has one of those sayings, some old hippie caught another hippie tripping on acid. Like you can however whatever works, make it happen. Okay? You do that? That needs to be in there. I'll give you a hint. You're not going to use sine, cosine, or tangent to answer this question. I mean, you could. It just be a long, drawn-out process, but to find the third missing side, you would use whose theorem? Pythagorean theorem. If that didn't jog some memories, hopefully this jogs some memories. If that didn't jog memories. Ooh. I hope you get this stuff really fast. Okay. To apply this, the most important detail is what C is. C represents the hypotenuse. A and B, it doesn't matter. It's just sides that are not the hypotenuse. So find an answer. Thumbs up when you're there. Correct answer is C, 12. Okay, you have a 3, 4, 5 triangle. There's also a 5, 12, 13 triangle. A little less popular, 3, 4, 5. That finds itself. Those are just convenient things to have. Okay. All right. I'm going to walk you through. Here are the questions. Here are the questions that you're going to ask yourself when you look at a triangle. First question. What sides do you have? Don't answer this out loud yet, but answer for this one. What sides do you have? You have the opposite and the hypotenuse. Opposite of this angle and the hypotenuse, which is opposite of the right angle. So then once you have identified the sides that you have, then you start looking for which trig function you're going to use. Which function has those two sides? And you go, sine has those two sides. So you have sine of 40 is equal to opposite over hypotenuse. Now, make sure your calculator is in degree mode. It should have a little D, subscript D or DEG. To switch that, some of you have a mode button. Some of you have a DRG button that you can press and kind of scroll through. But they need to be in degrees. If you're in radians or gradients, it's going to be a frustrating experience. Okay. So when you do this, you're going to bring 5 over. So 5 times sine of 40 is equal to B. If you have this kind of calculator, you're going to have to stick in 40 first and then hit sine. If you're using your Apple default calculator on your phone, you stick in 40 first and then hit sine and then hit times 5. If you have one of these calculators, a little more user-friendly, editable, you hit sine first and then 40. Okay. Correct answer is, all right, A. Okay, if you did not get A, you need to call me over. Okay, so here's the next problem. Call me over if you did not get A. Like, oh, we're going to walk around. This day is devoted to getting us to the point where you're like, boom, I know how to do trig. Okay, you're going to do this 5 times. Do that. 40 sine times 5. You must be in radians. You switch to degrees. Yeah. Okay. What sides do you have? Opposite and adjacent. What trig function uses opposite and adjacent? Tangent. So you have tangent theta is equal to opposite over adjacent. Everybody knows how to do 17 divided by 26 on your calculator. 0.65, okay, equals tangent theta. But this is where some people get derailed. How do you get the tangent over theta by itself? You get this cool function called inverse tangent. How do you do that on your calculator? You hit second or shift, and then there's the label right above tangent should be tan -1. That's inverse tangent. So you go inverse tangent 0.65 or inverse tangent 17 divided by 26 in parentheses. Correct answer is 33, eh? Okay. If you did not get 33, call me over, please. There's a next example. Call me over if you did not get 33 degrees on that previous one. You have to know how to plug this in your calculator. It is not hard. You just got to know how to do it. You use your calculator. If you don't, it's going to be a long year. It's got to be more than think. It's got to be like, oh yeah, this is easy. If it's not there, you need to pay attention. Thumbs up if you have an answer. Tell your neighbor. Tell them what trig function you used. Correct answer is? Correct answer is B. We okay with that? Okay. Your cosine 25 is equal to adjacent over hypotenuse. Okay. 3 times cosine of 25. Next. Correct answer is D. We all right with that? You used what trig function? You used cosine, so specifically inverse cosine. Good with that? Yeah. So your cosine and sine inverse, that has to be less than 1. Okay. So I don't remember what the numbers were. It was 90. Yeah. Okay. So you do inverse cosine. Cosine. You could do this 90 to 20. Okay. Okay. I put it in this 20. Okay. They're just shutting cabinets. Just super loud. All right. This ought to be interesting. Okay, here's some safety net type quality control things. Is it possible for it to be A or B? Why not? Your hypotenuse has to be the longest side. Catch that? Okay. So this is just the like does this make sense question. Okay. So if you got A or B, you did it wrong. And I'll tell you how you got it wrong. So what trig function are we going to use? Sine. So you have sine of 42 is equal to opposite over hypotenuse. Okay. If you got, I think A is the popular pitfall. You're like, oh, I got to get W by itself, so I'm gonna go sine of 42 divided by 7. That gets W by itself. Yeah, sort of, but that's 1 over W is what you just found. Okay. Here's my strong recommendation. If you have an unknown in the denominator, get it out of there. Put it up top. Okay. So what I would recommend doing is bringing W over here, multiplying by W on both sides, and then get W by itself while it's on top. Okay. Good with that? Okay. All right. That's as far as we got with everybody else. So call that good. If you would like more practice, let me know. No homework tonight.